Welcome to Study Loop.
In this problem on the topic of heat and the first law of thermodynamics, we are told to assume that the sun is a perfect emitter at 5500 Kelvin. We are then told to find the total power that is radiated by the sun into space, and then given the sun's radius, we want to determine the power per unit area that arrives at the Earth, provided that we know the distance from the Earth to the sun. So the total power emitted we know is Q over T, the rate of heat transfer. And this is equal to the emissivity epsilon times the Stefan-Boltzmann's constant sigma times the surface area A times the temperature T to the power 4. And we can write this as epsilon sigma, and we can write the area as the surface area of a sphere, which is 4 pi r squared, where r is the radius of the sun, times the sun's temperature to the power 4. Now all of these values are known. So the emissivity for a perfect emitter is 1 times the Stefan-Boltzmann's constant, which is 5.67 times 10 to the minus 8 watts per meter squared, Kelvin to the 4, times the surface area of 4 pi, and the radius is given as 7 times 10 to the power 8 meters, and that's squared, times the temperature 5500 Kelvin raised to the power 4. And so calculating, we get this to be 3.195 times 10 to the power 26 watts. And so, keeping our significant figures, this becomes 3.2 times 10 to the power 26 watts. And that's the total power radiated by the sun into space. Now, for the second part, we want to find the power per unit area. So we'll assume that the energy from the sun is distributed symmetrically over a spherical surface, with the sun at the center. So the power per unit area is equal to the rate of heat transfer, Q over T, over the area for pi r squared, where r is the distance between the sun and the Earth, so we'll call it RSE. Again, these values are known. Q over T we calculated to be 3.195 times 10 to the power 26 watts divided by 4 pi times the Earth-Sun separation, which is given as 1.5 times 10 to the power 11 meters, and that's squared. So calculating, we get the power per unit area to be 1.1 times 10 to the power 3 watts per square meter.